Our tank clearly is moving, but yet the log is still says 200, 200. The y is not changing. We know y is 200 here. Obviously, it's going to be whatever, 300, 400, 500, blah, blah, blah. And so that's not changing. So that's the problem we're fixing here. Welcome back to Arcade. I am Super Tommy. Now, in this video, we're going to look at syncing data back from Matter.js into our Phaser 3 Matter sprite. Now, before we do that, if you enjoy our ECS and Phaser 3 videos, be sure to like and subscribe for more videos on Phaser 3 and ECS. It is also the best way to support the channel. Let's talk about this physics sync problem. So we want the changes that Matter.js physics, that physics engine, does to our sprites, and we want those values in our components. So for example, our position component, Matter.js is going to move our sprite wherever it's going to do it based on the physics sim. So we want to be able to get that data in our position component so we can use it later in a future system to know where our entity actually is. And so to do that, we're going to create a Matter physics sync system, and it's just going to look at least in this case, the two components, position and Matter sprite, like we had for our Matter sprite system. And what it's going to do is for this system run after the physics update. So after Matter.js has figured out what should happen to our Matter sprite based on the physical interactions that it's had, it'll update the X and Y, and then after that physics update, we are going to take those values from the Matter sprite and put it back into our position component X and Y. So in Phaser 3, there is an after update event that you can listen to. This may actually be a Matter.js event that Phaser is passing along to us. So we can register that on the Matter world, and then when that fires, we're going to update our Matter physics sync system. Now let's see how that works in code. All right, let's code the Matter physics sync system that we just talked about. Now, we're in this Matter.ts file. This is where we've added our create Matter sprite system from earlier in an earlier video. So we're just going to put everything in this one file for convenience, and it's just easier to think about since all the Matter stuff can just be together. So what this Matter physics sync system needs to do is create a query for all entities, in our case right now, that have the position and Matter sprite components. And then after the physics sim has happened, we're going to get those values from the Matter sprite and put it into our position component. Now you can do that for any other components that you may need to do this for. In our demo here, it's just position, since we will be manually modifying velocity and rotation. But there could be other properties that you're going to want to sync back into a component depending on what you're doing in your game. So it would be the same basic premise here. So let's create this query. So const query, and we're going to do define query. This is from bitECS. And the components we want is position and Matter sprite. And we're going to do entities here by calling query, passing in the world. This will give us an array of all the entity IDs that match this query of having an entity having position and Matter sprite components. Now let's for loop over these guys. I less than entities dot length plus I. So we're not going to worry here about where the system is being called. All the system is going to care about is we're going to take a value from a Matter sprite. So let's do this. First we need to get the ID. So const ID, that's entities I. We're going to get the sprite that we've created for this entity, get ID. Now there's always a chance that something bad happened and we don't have a Matter sprite for this entity. It really shouldn't happen, but it can happen, possibly. So we'll just say if not sprite, we are going to continue. We're just going to skip this entity. We don't know what happened, it has no sprite. It has no sprite. So after that, we can guarantee that we do have a sprite. And so what we want to do is put the sprite's X position into our component's X into the array entry for our entity's position, for entity's X position. That was a mouthful. So I'll just, this code is going to be simpler to understand. So sprite.x, and then position.y ID is going to be sprite.y. What's going to happen is Matter is going to simulate whatever it's going to simulate, and it's going to have moved our entity. We want to know what that new position is in our position component if we're going to need to operate on that number later. So what we're doing here is for the entities X position and Y position for our component, we're going to put back the value that Matter has changed on our Matter sprite. So that's syncing the value back from the physics sim into our components. So let's, we've created this. This is good, I'm pretty sure. Let's now go into our scene and create the system. This is where it gets a little more complex. So we don't want to add it to our main pipeline here, because this is going to be, this is going to happen before Matter Physics runs its simulation. Now, if you do put it here, things will basically kind of work, but you may be off by 1 frame. So instead, we're going to do is create another pipeline here. I'll just call this after physics pipeline. And it's also going to be world void. And so what we're going to do in init, we're going to register for the after update event on the Matter Physics world. So if we do this .matter.world.on, now we can do after update as a string or just use Phaser's constant values here. Now if I remember where it is, physics.matter.events.afterUpdate. Okay, so that's the one we want, and let's put it in here. And so we want if this dot after physics pipeline. So if we don't have this pipeline created for whatever reason, I'm going to do nothing. Otherwise, we're going to run this after physics pipeline, and it's going to want the world. So we actually should check or not this dot world here. Great. So that's the basic setup here for calling something after physics updates. So now let's create our physics, our pipeline down here, our after physics pipeline. Very similar to how we create a pipeline above. Create Matter Physics sync system. It needs no parameters. So there we go. And then come here. So to demo this, we're gonna, let's go to Matter Sprite. So we are going to here basically call this query. I'll just write it out for you guys so it's not confusing. Const entity. So this is, so every update, if you remember, our query is going to give us all the entities that have the position and Matter sprite components added to them. So let's just go through all these guys every frame, and we're going to log out our position X and Y values. So console.log position.x, we want an ID. So const ID entities, nope, not enter, just entities, I. And let's log out y as well, so it's comma y. So this is gonna log out our tank's X and Y position. So let's see. So let's not make our physics pipeline yet. I'm gonna comment that out here. And let's bring up our bigger version of Chrome. Let's see, boom, big Chrome. Okay. So you see that it's logging here 200, 200, right? Our tank is not moving, so that makes perfect sense. Let's get rid of Chrome for a second. Let's go to our main.ts here. Let's just set gravity to something, let's say 1. Maybe too much gravity, 1.1. And we should see that our tank is going to fall. Let's bring Chrome back. Yep, our tank is falling. And you see this X and Y hasn't changed, right? Our tank clearly has moved. Let's just refresh this. Our tank clearly is moving, but yet the log is still says 200, 200. The Y has not changed. We know Y is 200 here. Obviously it's going to be whatever, 300, 400, 500, blah, blah, blah. And so that's not changing. So that's the problem we're fixing here. Now let's unshow Chrome. And let's go back to our matter scene. So we want to create our physics sync system here, and we're gonna call it here, so that's all good. Okay, let's bring back Chrome, and let's see. So now you see it has already fallen, but let's just refresh. So our tank is falling, and our values are now changing. So this is what we're expecting, right? We want in our position component to have the right values if later we want to check, you know, if tank Y is greater than, or is greater than something, destroy it, let's say. I just want one example of why you want the updated value. So now we see that that works. So we're almost done. I do want to talk about one more thing. That's cleanup here in this event that we're listening to, this after update. So the phaser scene init will get called every time the scene is started. So what we want to do here actually is clean up after ourselves. It's possible that phaser may already destroy this for us if we change scenes, but I'm not sure that it does. And you'd never know. Maybe it doesn't do it. It's always great if you add something, you create something, you also destroy it when you're going to shut down. So we can listen to our scene shutdown. So that is going to be this .events .on phaser .scenes .events .shutdown. Right, we've done this in other videos where we want to do some cleanup when we're leaving our scene. And actually this is going to be once. You can, every time you leave the scene, execute this callback. And what we want to do is do an off on our after update on listener. So to do that, we need to know what function is, a reference to the function being called. Let's call this on after update. And then we're going to do on after update here. And then here we're going to do the off. Boom. So now nothing is going to have changed with the logic. I'll show you. Let's bring back Chrome. Our tank is falling. Let's refresh. Our tank is falling and we're still logging out the right values, right? The Y is increasing. But if you were to leave this scene now, it will actually clean up properly. All right, so that's how we can make sure that our physics, our components can have the right values after Matter.js simulates the physics changes, so that we can use the correct data when we want to do something new to our entities. So that's it for this video. If you enjoyed this video, be sure to hit like and subscribe for more videos on making games with Phaser 3, Matter.js, the entity component system, and other web technologies.